Hello everyone. Today I'm here to present our project titled Head Controlled Wheelchair using MPU6050 and AT89S52 microcontroller. Myself, I'm Geeta and my teammates are Prashant Kanagasabai and Sabarish. This project was done as a part of our course Embedded System and Programming. We chose to design a head controlled wheelchair to support individuals with physical disabilities. I will explain the key components used in our project. The first component is the AT89S52 microcontroller. It is an 8-bit microcontroller. We used it to read data from the MPU6050 sensor and to control the motors based on the detected head movements. MPU6050 sensor, which combines a 3-axis gyroscope and a 3-axis accelerometer in a single chip. It provides the motion data in 6 dimensions: axle X, axle Y, axle Z, gyro X, gyro Y, gyro Z. In our project, we use only the X and Y axis of the acceleration values, that is, axle X and axle Y, to detect the head movements. These values helps us to determine the direction of the head tilt. The MPU6050 communicates with the microcontroller through the I2C protocol, and this is the AT51 developer board, which is a ready-made circuit board designed for easy development and testing of programs on the AT89S52 microcontroller. Board includes all the essential support circuits such as power supply, reset button, clock circuit, and the input-output headers, which are crucial for the smooth operation of the AT89S52 microcontroller. We used the L298N motor driver to control the direction of the wheelchair. It receives control signals from the microcontroller and allows us to control the motor electronically. The driver has 4 input pins, 2 for each motor. In1 and in2 control motor A, in3 and in4 control motor B. By changing the logic levels of high and low signals on the input pins, we control the direction of the motor rotation. I will explain the logic for motor A and B. When in1 is high and in2 is low, the motor A moves forward. When in1 is low and in2 is high, the motor moves backward. If both in1 and in2 are low or both are high, the motor stops. The same logic applies to motor A and motor B using in3 and in4. Now, to make the wheelchair turn, we rotate the 2 motors in opposite directions. If motor A moves forward and motor B moves in reverse, the wheelchair turns right. If motor B moves forward and motor A moves in reverse, the wheelchair turns left. Next, we have the LED, which is used as a status indicator. It turns on when the MPU6050 sensor initializes successfully through the I2C communication. Then we have the 9-volt hobby gear motor. This is a DC motor with an attached gear system. The gear provides better torque at lower speeds, which is ideal for driving the wheelchair smoothly and giving it enough power to carry the weight. We also used a 9-volt battery to power the entire system, including DC motors, microcontrollers, and the developer board. A manual switch is connected in series with the battery, allowing us to easily turn the system on or off.
Let's come to the coding part. We start by defining the microcontroller pins. An LED is connected to 3.0, SDA to 2.6, SCL to 2.7 and 4 in pins to 2.0 to 2.3. The I2C delay function is used to create a small delay in the range of microseconds. I2C start. The function begins communication by setting both SDA and SCL high, then pulling SDA low while SCL stays high. This signals a start condition. I2C stop. This function ends communication. It pulls SDA low, then sets SCL high and then finally releases SDA to high. The I2C write function sends a 8-bit of data one by one. It checks the MSB of the byte and sets SDA accordingly. Then it pulses the SCL line to send each byte. After all 8 bytes, it releases the SDA to let the slave send an acknowledgement. The I2C read function receives 8 bit from the slave. It sets SDA as input. Then for each clock pulse on SCL, it reads 1 bit into a variable. After 8 bit, it sends acknowledgement if more data is needed, or a knack to finish. Move forward is used to drive the motor in forward direction. Move backward is used to drive both the motor in reverse direction. Turn left is used to turn the motor left. One motor will rotate in clockwise direction and the other will rotate in anti-clockwise direction. turn right. This will rotate the one motor in anti-clockwise direction and the second motor in clockwise direction. In the main function, we turn off the LED and release the I2C lines. A short delay allows the MPU6050 sensor to power up. MPU6050 connections. We send the start condition and write the MPU6050 address requesting the OMI register. We then do a repeated start and read response. If it returns 0x68, the MPU6050 is working and we turn on the LED. MPU initialization. We write the power management register to wake up the sensor from sleep mode. Main loop. In the loop, we read X and Y accelerometer values. If tilted forward, the wheelchair moves forward. If tilted backward, it moves backward. Left or right, it moves in the according directions. Error handling. If the MPU6050 is not directed, the LED stays off and the program halts.